All right, how's it going? Today I'm going to be going over 242 valid anagram. And so essentially what this question is asking is the two strings are you given anagrams of each other. So essentially an anagram is just a word or a phrase. So if you rearrange the letters and you rearrange them in the same order, they're exactly the same. And they have the same exact letters and they have the same exact number of letters. So let's go to the blackboard. Essentially, S is equal to, so here in this question, you're giving S and you're given T, right? S is anagram and T is nagram in the first example. Now, if you sort them, which A, right? Then you have G, then you have N, and then you have M, and then R. So actually, it's in this case, oops. In this case, if you're sorting them alphabetical order, M would go before N and then R, right? Now, if they are anagrams, it should be the same. So A, G, M, N, and then R, which they are anagrams, so they are the same. So they are an anagram, right? And so that is what we're trying to see in this whole question. So how you want to go about this question, you can go about it a couple ways. Essentially, the easiest way to do this is you sort them, right? And then you set them equal to each other. And if they are equal, then it's an anagram, right? But if it's not, then it's not. That's the easiest way, but it feels too easy that it's cheating, right? So we're going to be using hash maps. So since we're using Python, in this case, it would be called a dictionary. So smap is going to be the name of our hash map for anagram. So for the S string, right? And so T string is going to be the hash map for, or T map, my bad, is going to be the hash map for the T string. And of course, they're starting off empty. But essentially, how hash maps work, or dictionaries in this case, is that, let's see here, let's get a cool color. So smap, so we're given a key and then a value, and that's how that works. That's pretty much all you need to know about hash maps, right? Given a key and a value. And how we're going to be using this hash map in this particular question is that, let's say, since smap is, we're trying to use it for anagram. I spelled that wrong. Oops. We're trying to use it for the word anagram. And how we're doing this in this question is that, let's say this first letter, right? A. A is going to be our key. And we've seen A once. So we create a counter for it. 1. And so since we're looping, that's how we're going to be doing this. We're going to be looping through every single character inside of anagram, right? And essentially we get A, and then we get the previous, we get like the default value. So the default value, since this is the first time we're looping, is 0, right? And so we see A, and we do 1 plus A, right? Because we're adding a counter. We're counting to it. So 0 plus 1 is then equal to 1, right? And then we go to n. So n, and then n plus 1 plus 0 is equal to 1, right? So we go back to A, and then now, right, we're doing 1 plus the previous value. And the previous value was already 1, so we're doing 1 plus 1, and then that is equal to 2, right? And essentially that's how that works. So we go to G, 1 plus 1, 1 plus 0 is equal to 1, and then we go to R, 1 plus the previous value, which is 0, and then that's equal to 1, right? and then we're back to A. So now, right, what we're doing is 1 plus 2. So is equal to 3. And essentially, we're counting how many times we've seen A, or how many times we've seen A, yeah. So then M1, we've seen M once. So essentially, when you haven't seen the letter before, where the default value is 0. And then you're adding 1 to it. That is how that works, and it works the same way for the T map, the other hash map. So let's start writing some code. Actually, before that, we have Anagram. Now, it should, if you look over here, what we did over here, right? What do these have in common? Well, they have the same amount of letters. They have the same letters, so A, G, M, and whatever. Now, if it's not an anagram, the length of both S and T should be different, right? So that's the first thing we're going to check. Now let's go to the code. So now if the length of S, the string S, is not equal to the length of T, then what are we doing? We're returning false because it is not an anagram. The lengths are different. How you want to see this is race car, right? And then, sorry, we have race cars. This obviously has an extra letter, and they're not anagrams, so you return what? False. Now, if we remove race car is an anagram, or in this case, it's a palindrome, but same thing, right? So in this case, it's true if you don't have the S. And so after we check, actually, let me do this, right? So if length of S is not equal to length of T, then you return false. And then let's start initializing our hash maps or dictionaries. So T map is equal to bang, and then that's how you initialize them. So S map is equal to this one, and then T map is equal to this one, and they are empty. We don't have anything in them. So what do you think we should do next? Essentially, after we initialize them, not initialize them, well, we create them, right? And then now we want to initialize values into them. We want to put values into them. So what we did in the Blackboard, essentially. So what we want to do is for I in range, let's see, length of S, right? So now, why are we choosing length of S? So in this case, we already checked if they have different lengths. So now the lengths are supposedly supposed to be the same if they are an anagram. So let's go back to the Blackboard. And what we're doing here is for I in range of length of S, which length of S is the same as length of T, right? They're equal. And in this case, what is it? Anagram 0, 1, 2, 3, 4, 5, 6. And then in this case, the length is 7. There is 7 characters. 1, 2, 3, 4, 5, 6, 7. There is 7 characters, and the indexes are from 0 to 6. Okay, that makes sense. And we always start counting at 0. So the length is 7 characters, and we start from 0 to 6. And how, let's see, let's remove this so I can explain this. So how this works, range, right? Range works from 0 to 6. So the length is 7, and it doesn't include 7. And it just goes from 0 to 6, not 0 to 7. This is wrong. So it goes from 0 to 6. It counts through all the characters, and in this case, since we have anagram, right? Let's put this again. 0, 1, 2, 3, 4, 5, 6. Since we're iterating through the first time, right? So it would start at 0. So essentially the first iteration is A, and then let's say you finish looping through it, you go again, and it starts at 1, and it swaps to the next. And that's how we're going to be swapping through every single character, right? So that's how that code of work. That's how that code works. And so let's go back. And so what we want to do here is these are empty. So we want to put what we did in the Blackboard into the hash map, right? So we want the key and the value, and the key is the letter, and the value is how many times we've seen that letter. So let's start off with smap, right? What is the key? The key is s, right? The string at index I. So this would be the first letter, and we're adding the first letter. So this is the key, right? This is the key. And then the value, what would the value be? So what we said before is the value was, right, 1 plus the previous value. And since we're starting this off, the previous value would be 0, right? So we would do 1 plus, right? And then we do smap. So the previous value is held inside of the hash map. So smap, and we want to get the value. So we want to get the value at s.i. What is s.i? S.i is the key, right? The key here is a, or let's see, I'll show you. So s is equal to anagram. What we're doing here is we're setting the key to a, and then we're doing, and then this is getting the value, right? This is getting the previous value inside of, okay, let's do it like this. Smap is equal to, right, key value, and then let's duplicate this. So essentially what we're doing is there's nothing here. There's nothing, right? That's how that would work. There's a key and a value, but there's nothing there right now. So now we're getting a, right? We're setting a inside of there, and then we're doing 1 plus the previous value. And then there's nothing in there. So the previous value is nothing, but so we want to set the previous value to 0. That is the default value we are setting. So we're getting the value at s.i. There is no value, so we use the default, 0. So now in this case, it would be what? 1 plus 0, which is what we were doing before. So that line is only for, like, adding this is only so if there's no value previously, you add the 0, which is the default value. Now, we essentially, this is pretty much, I mean, if we leave it like that, right, what is happening? So you're just looping through the string, and then you're adding it to the hash map, and this is only good for smap. So now let's do tmap. And so we want to go like this, right? We want to make sure we do everything the same for t. And that's pretty much it for initializing the hash map, right? So we're adding the value and then the counter. And now we want to check. Now what we want to do, so we want to loop again, but in this time we want to loop through. So for s in, I guess we can do smap, no? So smap. And so it's going through every character in smap. And then if smap at s, so at the key, so in this case, a, right? If a does not equal to tmap, let's see, the value at tmap. So tmap dot get, and then we're getting s and then 0, right? So 0 setting the default value if there isn't a value there. So how this works, let's go to the Blackboard because this kind of looks complicated now. So for s in smap, oops, this is lowercase smap. If, what is it, smap at s does not equal tmap dot get s at 0. Right, and so what .get is doing, .get is a function in Python that gets the value. It gets the value. Well, it doesn't look like that. You're actually, it gets, right? It should look like this. It gets the value, but you input the key, and if there is no key in there, you set it to the default value, right? And so essentially, for s in smap, right? So a in smap, s, the first iteration would be a, right? So you're getting the key, so a, and then this is going to return the value, right? So the top, this part is the key. Let me use a different color so it looks. So let's do it like this, red. So this is the key, and so when you're calling, sorry, this key, right? Key, and then when you call it, this looks dumb. Let's see. When you go right here, when you call it, you get the value, and then you're comparing it to tmap's value. So here you're getting the value, right? You're inputting the key to get the value. So essentially what it's doing is you're getting a, right? You're getting the key, and then you're putting in this, and then you're returning the value, which is 3. Now, tmap.get at s, right? So since there is, at a, right? The key is a, and then, so a inside of tmap, if it is an anagram, should equal to 3, right? And then they equal. Now we're testing if it doesn't equal, so then we return false, since if it doesn't equal. Now there's a lot of stuff on the screen, right? But essentially the whole point that I'm trying to make is, let's go back to the code. If the value does not equal the value inside of tmap, so if the value inside of smap does not equal the value inside of tmap, then we return false. Now that's pretty much it. That's the code. It iterates through all the characters inside of smap, or all the keys inside of smap, and then if the values aren't the same, you return false. And so if they are the same, you return true. And that is pretty much how the code should look like. Let's see. Yeah. So that's pretty much it. It's 242 valid anagrams.